And here you are, on Earth, 66 million years ago. It's one of the warmest periods in the planet's history. There are no ice caps yet. Everything is lush and green. Dinosaurs roam the Earth. Massive sauropods peacefully chew on flowering plants and trees, their young ones following closely by their side. You strain your neck to see their heads 5 stories above you. But that's when you see something else. A bright spot in the sky. A shooting star. Make a wish. Wait a minute. The star grows bigger, brighter. Little do the mass reptiles know, today marks the beginning of one of the largest mass extinction events in Earth's history. 3/4 of life on our planet will be wiped out. Hey, we'll just hide over here and watch. 5 seconds before impact. The meteorite rips a hole through our atmosphere like a needle in a balloon. The resulting supersonic shock wave starts to ripple around the globe. You'd hear it on the opposite side of the planet. The cosmic monster falling toward the Earth is the size of Mount Everest, at least 6 miles wide and weighing 460 trillion tons. The meteor is coming in hot and fast, 12 miles per second, heading right for the Yucatan Peninsula in present-day Mexico. At that speed, it could travel from LA to New York in under 4 minutes. Impact. The mountain-sized asteroid smashes into the Earth. If only it had been anywhere else, life on this planet might look a lot different today. The Yucatan Peninsula, almost entirely underwater then, was one of just 8 places on the entire globe that would have let a giant space rock wipe out nearly all life on the planet, meaning the asteroid only had a 13% chance of causing a mass extinction, and it happened to hit just the right spot. Well, aren't we lucky? At the point of impact, there's an explosion 1 billion times more powerful than even the most massive volcanic eruption. It looks like a new sun has appeared on our planet's surface. The meteorite digs into the Earth's crust and explodes into 1 million pieces. You can still see the scar it left. The Chicxulub crater is 93 miles wide and 12 miles deep. It could fit the entire state of Vermont and 24 Burj Khalifas stacked on top of each other. Something that leaves a scar like that has global consequences. The Earth ripples. The shock wave spreads for thousands of miles. The air blasts flatten forests in a second. Everything within striking radius is set ablaze. Nothing survives ground zero. But that was just the beginning. Smaller fragments of the meteorite, as well as parts of the Earth displaced by the giant hole it dug, go ricocheting out, reaching as far as Canada. The sky lights up with fireballs. They smash into the surface as well. Dinosaurs that weren't in the blast radius run in panic, but they have nowhere to hide. It's only about to get worse. The shock waves race across the sea. The tsunami is nearly a mile high when it hits the coast. The waves keep traveling, reaching the furthest corners of the planet. Even across the Pacific and up into the North Atlantic, they're 5 stories high. They wash away everything in their path. Besides the raging fires and skyscraper-sized tsunamis, the Earth is shaking from the worst earthquakes in history. A planet lush and teeming with life only a few minutes ago has turned into a nightmarish place. But this was only Phase 1. 5 minutes after impact. Small rocks, dust, and ash rise high up into the atmosphere. These objects heat up and melt. They turn into hot lava that begins to fall to the ground like burning rain. 10 hours after impact. Fires continue to engulf everything in their path. Some surviving dinosaurs in North America try to escape to unknown territories, but now they're in dense swamps and can't escape. 1 month after impact. 15 trillion tons, 2.5 million times the weight of the Great Pyramid of Giza. That much ash and soot are released into the atmosphere. The cloud covers the entire planet and blocks out the sun. The Earth sinks into darkness. Surviving plants can't photosynthesize. Oxygen levels drop. Any animals left at this point are finally done in from lack of air. But the worst consequence was the extinction of phytoplankton. The entire oceanic food chain starts to collapse like a house of cards. Many marine animals have lost their main source of food. Surviving animals on land also can't find anything to eat. There are no plants for the herbivores, and soon no herbivores left for the meat-eaters. And still, there's the acid rain. The Chicxulub meteorite hit a place where there was a lot of sulfur. The heat of the impact vaporizes the toxic gas instantly. It mixes with the air in the atmosphere. Acid rains fall all over the planet. The oceans become toxic. And if all that doesn't get them, the cold finally finishes off the job. With the sun blocked out, the burning fireball that is our planet starts to cool down. What's left in the wake? Plants are a little luckier than animals. Seeds and pollen are able to survive these harsh times. The first to slowly paint the charcoal planet green are ferns. The wind carries their seeds, sprinkling them across the earth over 10 years. Then come the palms. The new planets produce oxygen and feed small mammals. Of the reptiles, only turtles and ancient ancestors of crocodiles can survive the temperature and acidity of the planet's waters. Unbelievably, some bird-like dinosaurs survive too. Other species of birds evolve and survive to this day. Sadly, though, all terrestrial animals over 50 pounds in weight went extinct. It took much longer for the animal kingdom to recover. Larger mammals, such as rhinos, began to appear only 15 million years after the dinosaurs disappeared. Blue whales, the largest living creature this planet has ever seen, bigger than any of the dinos, only showed up a little over 4 million years ago. Did the dinos have a fighting chance? Scientists say that if the meteorite had hit in the deeper ocean, the story would have gone a lot differently. Yes, the resulting tidal waves would have been 10 times higher than the already massive ones that rippled across the planet. But even a giant mega tsunami wouldn't be able to wipe out 75% of plant and animal life on Earth. What really did the dinosaurs in was the global blackout. If the meteorite had hit in deeper water, not the shallow sea of the Gulf of Mexico, there wouldn't have been so much dust and ash in the atmosphere. That dropped the oxygen levels and cut off the food chain from the very bottom. There's a theory that climate change and other conditions on Earth 66 million years ago would have still wiped out the dinosaurs, no meteorite necessary. It could be a supervolcano erupting and spewing out large amounts of sulfur and ash into the atmosphere. Perhaps the meteorite just sped up the inevitable. Now let's move on to a more interesting question. Could humanity survive a meteorite impact like that? Back then, not a chance, obviously. But if something like that were to happen in our time, we have an advanced intellect and technology. We've filled the cosmos with probes and satellites, so we know about any possible meteors headed straight our way. It wouldn't take us by surprise. Now, we might have to hide deep underground to avoid the blast wave and tsunamis. And you'd need enough food down there to last for at least a year. And don't forget your toilet paper. But with the right prep, humanity could stand a chance. The main problem after such an event is to survive the global winter when the ash covers the sky. But our species can handle it. Just ask anyone living in Oymyakon, Russia. The town of 500 people holds a Guinness World Record for the coldest inhabited place on Earth. They've seen the thermometer read minus 90 degrees Fahrenheit. What about preserving plant and animal life? Our species has been working on that for a long time. There's a World Seed storage facility on Svalbard Island. It's about 40 stories underground and can hold over 2 billion samples. The location was chosen because of the permafrost climate and low tectonic activity. Preserving all the planet's animals would be a tougher job. Perhaps genetic engineering, cloning, or something else would work. Herding them all down into a bunker? Crocs, bears, and snakes included? I think I'd rather try my luck above ground, thank you.
Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the
Then you know the answer to this one. You can't hear sounds in outer space. It's not that sounds don't exist. It's just that you can't hear them. There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything. All you hear is silence. Complete silence. But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first! Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity. NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of negative 418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads, and we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated, though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey, smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with him on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they? Hey my dear astronomers, last year was awesome. 2 total lunar eclipses, a breathtaking ring of fire solar eclipse, and a rare alignment of Mercury, Venus, Mars, Jupiter, and Saturn. I bet you've been wondering what space wonders this year is going to bring us. Well, let's find out. From April 15th to April 29th, you'll be able to enjoy the Lyrid meteor shower. Meteor showers happen when our planet passes through debris left behind by comets and asteroids. That's why such showers normally occur approximately at the same time every year. The Lyrid meteor shower is produced by a comet called Thatcher. It takes around 415 years to orbit the Sun. By the way, this meteor shower is one of the oldest. People started watching it in 687 BCE. This year, the peak of the meteor shower will fall on the night of April 22nd, with almost 20 meteors per hour dashing across the dark sky. But if you missed the Lyrid meteor shower, don't worry. You can still see Eta Aquarid meteors from April 15th to May 27th. This meteor shower is famous for its fast meteors, leaving long, glowing trails. This shower is produced by the comet Halley, completing its orbit around the Sun every 76 years. Unfortunately, the full moon that will appear on May 5th might outshine most of the meteors, but astronomers promise it'll still be a pretty impressive show. Throughout all of June, Venus and Mars will be on the same astronomical line, looking as if they've been grouped together. And on the first official day of summer, Venus, Mars, and the Moon will form a triangle. You might even see the trio without any special equipment, since they'll be shining extremely brightly. And another meteor shower will start in July and last till September. It's called the Perseid meteor shower, and it's promised to be one of the best of the year. Bright and frequent, these meteors will have long tails and will light up the sky at a rate of 50 to 100 meteors per hour. The shower will peak when Earth moves through the densest region of space debris left behind by the comet Swift-Tuttle. On August 31st, you might notice that the full moon seems to be larger and brighter than usual. This phenomenon is called a supermoon. The moon, which follows an elliptical orbit, will be the closest to Earth. Even better, this year there will be 4 supermoons on July 3rd, August 1st, August 31st, and September 29th. And since there are 2 full moons in August, the second one is called a blue moon. It occurs every 2.5 years. On October 14th, people in the southwestern USA will be able to enjoy an annular solar eclipse. Now, look, solar eclipses happen when the moon passes between Earth and the sun. But this year, the moon won't cover the sun completely. That's why a dazzling, glowing circle around the moon will be visible from certain places. This eclipse will be quite short. It'll last for around 5 minutes. On October 28th, we'll also see a lunar eclipse, but partial. The thing is, a total lunar eclipse happens when the Earth's shadow covers the entire surface of the moon. But this time, the moon will pass through our planet's dark shadow only partly. By the way, there's one more type of lunar eclipse called a penumbral. It occurs when Earth's faint outer shadow, called penumbra, obscures the moon. And finally, we'll see another meteor shower from November 19th to December 24th. It's called the Geminid meteor shower. This one is one more fan favorite. Super fast meteors travel at a speed of up to 78,000 miles per hour. Another unique thing about this phenomenon is that the Geminids come not from an icy comet, but from a rocky space body, an asteroid. Astronomers still aren't sure how the asteroid named Phaethon produces meteor showers. There's a theory that it might actually be a comet that once lost its icy shell. Interestingly, Phaethon measures a mere 3 miles across. This is surprising because the amount of debris it leaves behind is truly impressive. Anyway, the peak of this meteor shower is expected on the nights of December 13th and 14th, when stargazers will see up to 120 meteors per hour.